Hello, so my name is Jaden Hill, and this is my lab report for the first lab of Physics 2212. So the purpose of this experiment was to explore the concept of electric charge on everyday objects. Electric charge is the property of matter that causes objects to experience a charge and place an electromagnetic field. So in this experiment, we used a piece of plastic tape to explore the amount of excess charge on the tape. By using Coulomb's law, we calculated the charge and the amount of atoms that can be found on the piece of tape. This allowed us to get an idea about how electric charge affects everyday objects. In part 1, we charged a piece of tape and looked to see how it reacted with neutral objects and another piece of charged tape. My initial prediction was that the tape would be attracted to the neutral object and the tape would be attracted to itself. However, it was only attracted to the neutral object, and it repelled the other piece of charged tape because it had the same charge. So what we concluded from this first part was that the tape was a positively charged piece of tape because we rubbed a pen against our hair, and that is negatively charged, and because the tape was attracted to it, therefore the tape was positive. It was not neutral because two neutral things don't repel. For the second part of the experiment, we took two pieces of charged tape. We put one across between two tables with about 16 centimeters apart. And then we took the second piece of tape and moved it closer underneath the charged tape that stuck to the table as shown in the picture. And we saw that it caused the top piece of tape to bend upwards from its original position. Next, we calculated the charge on B by using the gravitational force, which was equal to electric force. After using Coulomb's law, we were able to find that the charge on tape B was 2.07 times 10 to the negative 9 coulombs. Next, we calculated the ratio of electrons to atoms in on a piece of tape B, or the fractional loss. So first we found the amount of electrons on there by using the charge we calculated in the previous slide divided by the charge of an electron. That gave us 1.296 times 10 to the 10 electrons. Next we calculated the area of the atom and the area of the tape and divided the area of the tape by the area of atom to get the total amount of atoms. Lastly, we calculated the ratio of the two, which was 5.19 times 10 to the negative 9 electrons over atoms. Next, we confirmed our results by using a computational model. Okay, so this is a on the left is a picture of the code that I wrote to calculate the charge on piece of tape B. Essentially, the formulas are the same. If you look in the charge function, instead of using D, I use R in case it was as a vector because usually it's a vector, so I decided to keep that in the code. The computer managed to calculate the same charge as I did before. So these are some questions to think about after concluding the lab. For the first part, if everything was opposite, then the observations we made and the things we calculated, the sign would be opposite because the sign of the tape charge would be different. So instead of positive, it would be negative. It is important to handle charged tapes as little as possible because they can lose their charge. As I saw in lab, multiple times. When charge tapes come in contact with my hands, or the objects the charge rubs off on me, or they become a little less charged. That is the conclusion of this lab. Thank you all for watching.